Right. So for organic reactions, these what you call abbreviations, right? That you know, I got from most people, right? They are very, very useful, right? I found them to be very, very useful. So first of all, we must remember, for us to understand this, we must remember what are saturated and unsaturated compounds, right? So yeah, I'm gonna start here. Let me do this. So let's remember that an unsaturated compound is a compound that has two or more bonds between the carbon atoms. So to be honest with you, we are only going to deal with this. When I'm saying unsaturated, I mean a double bond. Okay, we don't really deal with a triple bond in grade 12. Then when I'm saying saturated, I'm referring to a single bond. Saturated, single. Okay, so a way to remember that what is an addition reaction, remember it's when we say USA, which means that I'm moving from an unsaturated compound. Remember, un. Did you say single? No, you said un. That means you should have double bond there. So unsaturated to a saturated, meaning to a single bond, then it means that type of reaction we would call it an addition reaction. I hope that spelling is correct. A will mean the addition reaction. So the only way this is going to be possible, good people, is if you break that double bond, right? You are breaking the double bond. That is the only way it is possible. And then let's remember that SU will mean that you are talking about from saturated, which is a single bond, to to an unsaturated, which is a double bond. That type of reaction would be elimination. Sorry, that is I'm right, that would be elimination. So I just want to write it properly here. Elimination. So the E here would be for elimination. Then let's remember that reaction takes a lot of strength. Takes a lot of strength, right? Takes a lot of strength. You can imagine forming a bond, like you see you're moving from a single to a double. That's not easy, good people, because if you are doing that, this means you are forming a double bond. Okay, let me write it like this means you are forming a double bond. You must know that elimination is the reverse of addition. Addition, you break the bond. Elimination, you form the bond. So these ones, they are reverse operations. This is why usually when you are answering questions and then they give you a box and then they do something like this, a box again, and then they do this, right? They do this and then they do that. They say this is a reaction 1, reaction 2. If on top it was addition, on the bottom it's gonna be elimination. That's always how it works. These two are very much working hand in hand. So far, addition. Yes.
So is it safe to assume that, let's say you don't know, but you see the two arrows facing each other. Is it safe to assume that?
Yes, very much safe.
Okay.
Are very, very much safe. Okay. Okay. So that is elimination and addition, and we have to remember that addition, right? In terms of addition, I'm gonna write here that actually these are the conditions for addition reaction. If they say what type of addition reaction is it, remember you are breaking a bond and then you're going to be putting in some elements. Just as an example, so for us to recap what is addition, right? Let's take an example and say, let's say I have the following. Remember, it's unsaturated, which is a double bond, right? Double bond. Oh, sorry. 1, 2, 3, 4. Yeah. So if I have a double bond like this, right? If I bring along a hydrogen gas, right? If I bring along hydrogen gas, well, if they say use structural formulae to show the reaction, I must remember that hydrogen could be written like this in terms of structural formulae. I must remember that we can write that hydrogen as H bonded to H. Right. Now, what is going to happen? We are going to have this, the very same thing. Yeah. We are going to have the very same thing here. Okay. But what is the difference between this original and that one? Is that we are going to break this double bond. We're just gonna remove this smaller yana part, and then it's going to split into two. That part is gonna split into here and there. You see, you had it like this. That's how it splits there. Split into two. Right. And when it splits, what happens? This hydrogen then goes there. So we put the hydrogen here, then the other hydrogen there. So what have we done? We have moved from an unsaturated compound to a what? A saturated compound. So we call this a what? An addition reaction. Right, it's an addition reaction. But what type of addition reaction? Because you added a hydrogen, we'd call this a hydrogen. The way it is, you added a hydrogen, right? We call it a hydrogen. Then we just put the Asian there. So that would be hydrogenation reaction. But for it to happen, right? For it to happen, this could take years, good people. To move from, remember this is an alkene. This is an alkene. You have actually formed an alkane. These keywords I'm writing here should give you an indication on the questions that actually you might be talking about in addition. Say it's a hydrogenation. So to move from an alkene to an alkane, that's addition. And it can take hundreds of years. You understand me? Hundreds of years. So for it to happen fast, you need to have a catalyst. You can use platinum or you can use nickel. So usually they show it on the arrow itself to say we are using a what? A catalyst. So that is then called a condition for the reaction to occur. It's called a condition, because if it doesn't happen that way, if we don't have platinum or nickel, you can have an alkene. This is an this is an is what? This is an ethene, right? You can have that ethene and then you have hydrogen in a container, and they will not react unless if you do what? Unless if you put platinum inside or you put nickel inside, then it will occur fast. So that is the condition, right? So you must remember that. You must remember it by heart to say for me to move from an alkene to an alkane, right? I will need platinum or nickel. Okay, that is the first type of addition reaction that we have. This is still addition reaction. Ooh. Yeah, like this, addition reaction. Right, and then just still on them, right, to further maybe understand more, I'm gonna take the very same thing I had. So I'm gonna take this, and then now say, okay, I have that, right? I have an alkene. This is still going to be an addition reaction, right? On the other one, we moved from an alkene to an alkane. We said that is hydrogenation, right? That is hydrogenation. So this is still an addition, but I want you to check, right? We still have a double bond, but now I'm going to add something. I'm going to add hydrogen with chlorine, hydrogen chloride. Do you remember that hydrogen chloride is actually an acid? So actually, I'm combining, what am I combining? I'm combining ethene, and then I'm putting it inside of a hydrochloric acid. I'm putting it inside of hydrochloric acid. What is going to happen? The double bond will break. Oh, yeah. The double bond should break for sure, because you are adding, the moment you are adding something, right, again this is plus, you are adding something to a double bond, and the double bond must break. So it's gonna break there and split into two. Right, when it splits into two like that, that's when the hydrogen and the chlorine, they come inside. Let me write it with white so that you don't feel like it's something new. The hydrogen is here and then the chlorine is there. Now you can see, what have you formed? You have moved, right? You have moved from an alkene to a what? A halo alkane, because now you have a halogen, right? To a halo alkane, which is you have moved from an unsaturated compound to a what? To a saturated compound. So it is an addition reaction. It has single bonds there. But what did you add? You added a hydrogen and a halogen, right? So what would you call that? You call that, you say you added a hydrogen and a halogen. So you're gonna call it a hydrohalogen. The hydro standing for what? For hydrogen, and then the halogen. Hydrohalogen. Then just put Asian to say this is the type of addition reaction. It's called a hydrohalogenation. So it is this one here, right? Usually say that when you are putting, if you are adding H and X to an alkene, you're going to form a haloalkane, whereby X is a halogen. Okay, so from this to that type of reaction is a hydrohalogenation, because you have put a hydrogen bonded with a halogen. The condition is that there must be no water, because if you have water, that reaction won't take place. You must have no water for that hydrohalogenation to occur. Why must you not have water? Can someone tell me, what do you think we must not have water there? Here you are, it's a container, ethene, yeah, ethene and a hydrochloric acid, and then there's water inside. Why should we
Won't
look
the
at
acid completely? Oh, sorry. Won't the acid completely ionize in the water since it's a strong acid?
Definitely. The acid would ionize in the water and then the reaction does not take place. Definitely. So that is why we say you must have no water present for that reaction to take place. That is why having no water is one of the conditions. So when you remember a hydrohalogenation, try to link it with HCl so that you always remember that there must be no water present. Right, perfect stuff. Perfect. Then you know what I'm gonna do? I'm simply gonna do this because rewriting, hey, copy. Then right, this is what we have. But here now we are going to add something else. Instead of a chlorine here, or instead of a hydrogen, I'm gonna put another chlorine. Aha. So that means now you have ethene plus what? Plus chlorine gas. Ethene plus chlorine gas. Of which chlorine gas you know it's Cl2. Right. What type of reaction is that? Is there hydrogen here? There is no hydrogen. So that type of reaction should be a halogenation because you're only adding a halogen. But what are you going to form here? You're going to have chlorine, right? So you're still forming a haloalkane. You're still forming a haloalkane. So that reaction, we call it a halogenation because you're only adding a halogen. But what is the condition, right? The condition is that for that to happen, chemistry says some reactions, for you to spark those reactions, right, to force them to occur, you need to have some external forces on that closed system. And one of the things you can do is to put UV light. Okay, UV light. So if you put UV light on that, shine UV light on that, trust me, you are going to have your what? Your dichloroethane. Dichloroethane. You are going to have it if you just shine UV light there. So this type of addition reaction, we call it a halogenation because you're adding a halogen. So you're going to form a haloalkane, right? But you need to have UV light inside for that to occur, right? And then now let's say you don't add a chlorine. Oh yeah, so here usually you'd put there the condition again. You must have UV light for a halogenation. UV light for a halogenation, no water for a hydrohalogenation, PT or nickel for a hydrogenation, right? And then let's say we don't put this one, right? Let's say we put there, we want to add we've added a hydrohalogen, we added a halogen, we added hydrogen. The only thing that is left is to add water there, right? So water, we can agree that it's HOH, right? That is water there. So in a similar fashion, right, it's going to come there. H is gonna go there, and then you're gonna have OH going this side, right? OH going there. Then what have you formed? This is not a haloalkane because you don't have a halogen, but instead, because you have OH, what did we form? An alcohol. Yes, an alcohol. because an alcohol, remember, OH is the hydroxyl group, right? It's the hydroxyl group. So yeah. And then now what type of reaction is that? You added water, right? That is water there that you added. So because it's water, we would call that a hydration, not hydrolysis. Hydration. Hydrolysis is for substitution. Please, let's remember that. Hydration. So hydration means you are hydrating the compound, right? You are hydrating that ethene. You are putting water inside of it, right? You are drowning it in water, right? So for you to do this, the condition is simple. It's nothing really rocket science. For you to have the reaction occurring, make sure that you have excess water. Just make sure that you have excess water, so that you keep putting what, so that like that thing should be in a water bath, right? It's like but if we say water bath now, we are saying we should have even heat. Here we don't need heat, we just need excess water for this thing to occur. Or you can say you need maybe a dilute sulfuric acid, right? Having a dilute sulfuric acid or a dilute phosphoric acid, that can very much well assist, right? So that type of reaction there is an addition, and then the type of addition is hydration. Okay, then you form alcohol. So you must always remember that if I have an alkene and then I add water into it, I'm going to form an alcohol. And that alcohol there, for me to form it, I must have excess water or dilute sulfuric acid or a dilute phosphoric acid. Those are one of the conditions. Okay, so the summary for that would be given here. I'm so hoping that you are able to see. For hydrogenation, we need platinum or nickel. For halogenation, we need UV light. For hydration, you need dilute that. For hydrohalogenation, you don't need to put water. Okay, and you should be okay. Those are the conditions that, unfortunately, we must know these ones by heart. There is no way they're gonna be given to us. We must just know them, right? Okay, then apart from addition reaction, right, because we only discussed the USA, there's also elimination, but we already said elimination is the opposite of addition. If I'm removing hydrogen, I will call it dehydrogenation. If I'm removing halogen, I'll call it dehalogenation. And then if I'm removing halogen, that will be dehydrohalogenation. You see, and then yeah, so elimination is just the reverse or the opposite of addition. So now it means we are only left with two that we must then know, right? And then these two is what oh, by the way, now that we said elimination is the opposite of addition, the only thing that is different in terms of elimination is that elimination doesn't have so many it doesn't have so many what you call conditions. If you just have something like this, if you have something like this is a saturated compound because it's a single bond, and then if you break it down, if you remove these two here, if you remove them, so removing is what? It's minus. It's what? It's minus. You are removing HCl. Then what are you going to form? Because you have removed those two, right? If I take this here, because you have removed those two, that will mean that you have this you remove those two, that will mean that they are gone. They are gone. But if they are gone, do you think they just, okay, it's fine, they are gone for now. Now it means you have to remove here, and then you have to put what? It must close itself. You have removed them again, they were here. If you remove them, that thing must close itself. Then you are returning back to a double bond. So you have moved from a haloalkane to a what? To an alkene. Which means you move from a saturated to an unsaturated. We must sue you for that. So it's an elimination reaction. Understand me? That will be an elimination reaction. What did you remove? You removed a hydrogen and a chlorine. That means the type of elimination reaction is dihydrohalogenation. Okay, that is what we're saying. But in terms of chemistry, we don't really like you to put the negative there. We don't like those negatives. So you are going to do a bit of maths. You understand me? You're going to do a bit of maths. I'm using structural formulae because I know they like saying use structural formulae. You're going to do a bit of maths. If you take this to the right, what happens to the negative sign? It changes, right? Yeah, it should change. And if it changes, right, it means on the right hand side, you are going to have, first of all, you're going to have this. Let me take it. You're going to have this, and then now you're going to have this. And here I'm taking it to the right. But once I take it to the right, what happens? I should have a plus, because it changes the sign. Then this is how you show an elimination reaction using structural formulae, which means you have moved from a chloroethane. You've moved from a chloroethane to what? To an ethene plus hydrochloric acid. And the condition is very, very simple. Here are the conditions. Here, for elimination, which is CE, we usually use the acronym CATS to assist us. So we are just going to need, for elimination, it's not easy, good people. It's very much not easy to eliminate something. So the condition will be that you must use, there are only two. C should remind you that it must be a concentrated, strong base or acid. Concentrated, strong base or acid, number one. Number two, you also need strong heat. You understand me? So usually they can represent it here by saying, you can represent it by putting a triangle for heat and then saying concentrated, maybe H2SO4 because it's a strong acid, or sodium hydroxide because it's a strong base. So we are only dealing with strong acids and bases. Okay, that is what is needed. That is just the condition for elimination. You can even have other type of elimination reactions, like you can remove a hydrogen. If you find that in the alkene you have two hydrogens, right? You can play around with them, good people. Then you will just see what you form there. But this is the structure you must follow, right? As much as elimination is an opposite to addition, in terms of conditions, please quote me well. In terms of conditions, the last one, in terms of conditions, elimination reaction is an opposite for substitution reaction in terms of the conditions. Because the conditions for elimination says concentrated, strong acid or base. But for substitution, we say dilute, even though we're still saying strong acid or base, and then we say mild heat. So they are like the opposites. So that will be the DS part. So in terms of conditions, elimination and substitution are opposites of each other, right? But what is substitution reaction? It's when you move from a single to a single. Okay, like as an example, let's say you have yourself C, H, that will be in what? A propane, right? You take propane gas or just propane and then what do? You say plus, right? And then you take maybe what you call oh, you want to substitute, right? You substitute, you take HOH, right? Yeah, you take H and OH. What will happen there, right, is that the other one will be substituted, right? So this can go and substitute this one, and then this will then go there, right? Which means, what are you going to form? This one that you previously had, right? What is going to happen to it is that that hydrogen will no longer be there, but rather will be substituted with the OH. Okay, will be substituted with the OH. So that will mean that now, instead of having OH here, you now have what? H and H. You have hydrogen gas. So you have moved from an alkane to a what? To an alcohol. That type of reaction is a substitution reaction, because you are moving from a single bond to another single bond. And because you added water, we call it a hydrolysis reaction. Okay, we call it hydrolysis. The conditions are the opposite of elimination. You must have mild heat, and then you must have dilute, not concentrated, dilute, but it must be a strong base or acid. That is substitution reaction. Okay, that's what we must just remember. Speaking of concentrated, the last type of reaction is esterification. And esterification, you must just know that there you need concentrated sulfuric acid and heat. Okay, this is just conditions for esterification you must know. Remember, esterification, we are adding an alcohol plus in what? An acid, a carboxylic acid, to form an ester. Okay, how does that one work out? So we can see, right? So in terms of esterification, you can have yourself an alcohol here. This is an alcohol. I'm taking a primary alcohol. What is the name of this primary alcohol? It's not ethanol, but it's propanol. It's propanol. Now, I take a carboxylic acid. Let me say, remember the functional group for carboxylic acids is H bonded to C, double bonded to O, and then it's like this. So when it's like this, it allows for what? For other carbon atoms. Is this correct? Yeah. No. Hey, I hope I'm not making a mistake. Yeah, you should have HO like this. 2 3 4 1 2 1 2 3 4. Yeah, then you can have others. Is this correct, ma'am? Am I not making a mistake in terms of the carboxylic acid there? Especially the functional group. Yeah, it's very much correct. Very much correct. So the name of this one, right, it's just 1 2 3 4. That will be butanoic acid. Butanoic acid. What is going to happen, right, when it meets this guy? Well, what is going to happen is that here, this should go, right, and even let's see, this also should go, so that these two, they can attach to each other, right? Oh yes, because we must have water as a product. Actually, we must remove H. We can remove this H, and then we can remove this OH there, right? If we do that, what is going to happen? Immediately, this guy, right, this is what this guy is gonna do. I'm gonna draw it here because of space, guys, né? So what is going to happen then is this, it's gone, right? It's going to go, and once it goes, this one that was here, it then shifts and comes here, okay? Because Angerate was left here, now it shifts and sits there. It opens up a space for a chain. This one is gone, right? This guy here is gone, so we have to remove him. Good, he's gone for good. Now that we have that, what happens? Now they come and join. Hey, now they come and what? They come and join. Gosh. Then what do you have? Cocoa. The moment you can now read the word cocoa, you have formed an ester. You have formed an ester. But where does the water that was removed go? That water then comes back. No, man. It forms one of the products. So it will be here. Forms one of the products. To balance, remember, Gary, the law of conservation of mass means we must have the water there. So you have formed an ester. But how do you name your ester? I always say, from the side whereby you can read the word cocoa, right? From the side whereby you can say, you know, when you read, I can't say oko, I will say cocoa going up, right? Cocoa. So because of that, from the side whereby I can read co, right? I want you to remember that if people want to drink alcohol with you, they are going to call you first to find whether you are available. So from the side whereby you can read co first, that will be the alcohol side. Okay, this will be the alcohol side, and that alcohol side is going to serve or act as a substituent. Then the other side is going to be the carboxylic side. So the side whereby you can read the word co first, that will be the number of carbon atoms that are there, will be the substituent. So you're gonna say the name of this is going to be, there are three, right? So the name would be propyl, and then from the carboxylic side there are 1 2 3 4, so that will be butanoate. Then that will be your acid, your ester. Okay, so on the side you read co first, that will be the alcohol.